What is up, everybody? Welcome back to this video. And basically in this video we are basically going to be making a half-wave rectifier. So what you see over here is a half-wave rectifier, and what you see over here is a half-wave rectified signal. The blue signal you see here, it goes up and then stays silent for a bit, goes up again, stays silent, and goes up again. First, we're gonna go through the fundamentals of a half-wave rectifier. A half-wave rectifier is a rectifier that basically uses one diode, which you see over here. It uses one diode because usually we have an AC. Okay, not usually. Because we're with this rectifier, just switch it to DC current. This is what we do. We use filtering and regulation after this rectification. So what you see over here is our input. This is our input, which is 15 volts, 50 hertz. So that is an AC current. That AC current is going through our transformer. Very sorry, why we're using two ratios. So we're using one ratio for this transformer to reduce the voltage that's coming from the AC current. Most of the time, that's what we do for phones. Most of the time on the phone, on the input, we have 220 volts. Now to reduce it, we use a transformer, which will most likely switch it to 5 volts. So you can imagine the amount of turns that a transformer will have. So what you see over here is after transformation, it's gonna go through the diode. So when it's going through the diode, I don't know how I can show this, but it's gonna take this to be our current. The current is gonna go through the diode in this direction. This direction right here, this direction going this direction. But usually in AC, it's basically reversible. So the AC goes like this and like this. So the AC goes from positive to negative, from positive to negative. So that's how AC current works. That's what is given because of the magnetic change. Usually because of Faraday's law, which you probably learn in high grade. So what you see here is when the AC current goes like this, it will be allowed by our diode. If you see the diode's basic placement, you can see in this direction it's going to allow AC current. But if it goes the other direction, which you see this, take this to be like a blockage gate, it's not going to allow that AC current to pass through. So now that we have put down the fundamentals of our diode, just think about these three components over here. The resistors, just to ensure this diode does not basically get damaged or anything. And of course, here we have a sine generator. This sine generator is basically going to be helping us to see this graph over here to know whether it is rectified or not. And we need a ground because of the negative over here. So again, because these are our values we're gonna use later, we're just gonna copy them. Anyways, so we're just gonna simply start. Over here. Sorry. So now what we need to first get initially is let me get that real quick. Our first thing which we're gonna get, of course, is this input voltage over here. You see over here. So you can find the input voltage from the command library over here. You can go through it and find any input source you can find. Technically you can use, and we're gonna assign it to these values. We're gonna have 15 volts. This part is for the volts, this is for the hertz, and this is for the amount of steps we want to read. So going after that, just gonna keep this ground back there, is we're gonna need our transformer, because maybe this power supply is gonna be for our phone. So we're just gonna get our transformer over here, and in this case we want it to be a 1 ratio change transformer. So the more ratios, just for your information, the less the voltage. So we're just gonna connect both of these using the wires over here. And after that, now we need to think. Now we need a diode. This diode is the basic foundation in which is going to rectify our signal, rectify our voltage over here. So we're gonna connect it to the transformer over here. And basically like these three components is enough for of half-wave rectification. But of course we're gonna need our resistor over here just to enable just to ensure this diode does not get broken. Now we're just gonna connect like that. Sorry, we're just gonna connect like that. Great. So now after this we just need to just complete the circuit like this. Great. So this already is enough to give us a half-wave rectification, half-wave rectification graph, or half-wave rectification current. What we see over here is our resistor, our diode, transformer, and our input voltage, which is 15 volts at 50 hertz. So now for us to read this, because right now if I just come here and save and actually run this, we are not going to get a graph. As you can see, it's going to go loading forever. So now to enable us to get this graph, first of all, this sine generator needs ground input over here. So this sine generator, you can find it from here. You can just place it anywhere over here. So what we're gonna do now for the sine generator is we're gonna connect channel B right directly to after the input, after the output of the diode. And again, we're gonna maybe want channel B to see the rectified input, rectified output. So what we're gonna do is we're gonna have the channel B to be after the diode, right after the diode, so we can get the half-wave rectification signal right here. So if you want to see before that, we can just come to channel A, which could read over here, channel A, and we put it before the diode to see how the graph looked like before that. And since because this line is sharing ground, we'll just simply just share them like that. So if you remember well, this is the same circuit we had at the start. So what we'll just do is we'll save, and finally what will happen is we are going to get a half-wave rectified signal. We can definitely, for our viewers purposes, we can definitely just remove channel A for better viewing. Now for you to see it well, I just remove channel A so you can only see channel B. So as you can see, it goes up. This is the first part of the AC voltage. It goes up to positive, and because now it's going down, because it's AC, it's going simultaneously positive to negative. It's gonna go down, and when it's going down, the voltage is going reverse. So the diode over here is just simply going to refuse that to go through, and it's going to have some time where we don't have anything, and then again it's going to go up. It's going to allow that positive voltage, and again it's going to refuse it. We can see this clearly from here. This is the yellow line you see over here is the AC voltage going up and down, up and down, up and down, from positive to negative, etc. So what this blue line you see over here, it goes up, positive, refuses negative, up, positive, refuses negative, up, positive, refuses negative. For this whole line of negative, we have nothing. We literally have 0. So that's it for this video. That's all we are going to be talking about inside of this video. If you definitely like, please like and subscribe. And yeah.